Hey there, it's me, Miss B. And in this video, we are actually looking at a lesson or two from the eighth grade content in Illustrative Math. But it's relevant to the Algebra 1 content that we're learning in my class. So these are the practice problems, or practice, they're not all of them, but they are the practice problems from lessons 3 and 4. So let's take a look at this first question here. In this hanger, the weight of the triangle is X, and the weight of the square is y. So I'm going to say the triangle is x and the square is y, which means we're just going to label each of these and see how many we have on each side. Now, they're asking us to write an equation using x and y to represent the hanger. Since both sides are supposed to be equal, what we're going to do, excuse me, what we're going to do is create um, just each side is going to be its own like side of the equal sign. So we would have x, and then there are three y's, so x plus 3y equals, and here we have four x's and one y on the right-hand side, so 4x plus y. And that would be our equation to represent the hanger. Now what they're asking here in the second part is that if x is 6, what is y? So that just means we're going to replace x with a 6 and try to solve. So 4 and 6 plus y. So this creates 6 plus 3y equals 24 plus y. I'm going to subtract 1y from both sides. 6 plus 2y equals 24. And then we're going to subtract 6 from both sides there, and we'll get 2y equals 18. Last step is to divide by 2, and we'll get that y is equal to 9. So if x is equal to 6, then y is equal to 9. All right, for question 2, Andre and Diego were each trying to solve an equation 2x plus 6 equals 3x minus 8. And so we want to describe the first step they each make to the equation. So the result of Andre's first step was negative x plus 6 equals negative 8. So the plus 6 here stays the same, but it's our x values that are changing. So it looks like he doesn't end up with any x values on the right-hand side. So it most likely looks like Andre is subtracting 3x from both sides. And if we check here, 2 minus 3 is going to give us negative 1. So I will write out that Andre is subtracting 3x from both sides. The result of Diego's first step was 6 equals x minus 8. So in this case, the x is the only thing that's moving again, but he's missing the 2x on the left. It just is the 6. So it looks like he took the 2x and moved that instead. So here he's actually subtracting 2x from both sides. Both of these would function to get all of the variables together on one side of the equation. It's just going to be different sides of the equation. Okay, for question 4, we're supposed to match each set of equations with the move that turned the first one into the second one. So we're looking at what happens in the first one to create the second one. So here, what looks different is we still have the negative 3's, but I'm missing a 4x. So it looks like I'm maybe subtracting 4x from both sides. Now you'll notice that I only have multiply and add for options over here on the right. I have multiply and I have add. So I can add a negative, and that's the same thing as subtracting. So for this answer, we're going to say that A is adding a negative 4x to both sides, because that is what would remove that 4x. Now for B, it looks like we're dealing with this negative 4 out front here, and what we have left is just what's inside the parentheses. So instead of distributing it through, it looks like they maybe divided both sides by that negative 4. Now, if we're thinking that we're dividing, again, we only have multiply and add. So if we can add a negative, and that's the same as subtract, we're going to talk about multiplying by a fraction, and that would be the same as divide. So I don't want to multiply by negative 4. That would be number 2. I don't want to use that one, but it is got to be negative. So I'm going to use multiply by negative 1/4, and that will actually be our answer here. For part C or choice C, we have 8, and then I see the 10x is staying the same, so it looks like something with just the constant numbers here. And that, again, is also what appears to be the same on this side. So 7 is changing to 3, so that seems like I am subtracting 4 from that. And likewise here, this would also work by subtracting 4. So again, we're going to use the add negative to our advantage here, and say that we are adding a negative 4 to both sides, and that would have the same effect. Okay. Now, as we continue going, we have basically negative 5x over a fraction, and then here we have just 5x. So we want something that would get rid of the denominator of that fraction, and we also want something that would change it from negative to positive. So we're going to multiply by a whole number here, and we really only have two choices. We're either going to multiply by negative 4 or positive 1/4, and we are going to choose negative 4 in this instance because the negative would change it from positive to negative, and multiplying by a whole number is going to get rid of the denominator on the first equation on the left-hand side. So we have one choice left, which is E. We're going to double check because I never like to make assumptions that my last option works. I'm going to check that it does. So they're saying we should be multiplying both sides by 1/4. That's the same as dividing both sides by 4. And if we check here, it does look like, yeah, both of those pieces get divided by 4 to create the next ones below. And same thing here. Yes, these are going to get divided by 4. So we are correct. And I'll continue with my pattern of going every other color here. And we're going to match that up with multiply both sides by 1/4. So that is that one. We have one more down here. It is a little bit misnumbered, but we're going to solve it anyways. I know there's not a number. There's already a number 2 on the front, and then we have a second number 2, but we'll solve this one here. So we have two options. We can either divide by the number in front or we can multiply it through. Now, I like to divide by the number in front, but that's only a good choice if both sides are divisible by that number. So I can choose to divide by 3, but I want to make sure that my 12 over here, that this one can divide by 3. And since it can, then I'm going to use this method. So when we divide by 3 on the left, the only thing we have left over is x minus 4. And that was on purpose. We intentionally had those cancel out. Now on the right-hand side, 12 divided by 3 is 4, and the x would remain, so we would have 4x. From here, we don't have very far to go. We can actually just drop our parentheses and say this is x minus 4 equals 4x. And I want to get all of the x's together, so I'm actually going to subtract x from both sides, or subtract 1x, and have -4 equals 3x. And my very last step is to divide here by 3. So what happens is this becomes 1, and my x is then going to be equal to -4/3, or -1 1/3, or -1.3 repeating. These are all the same answer, just the different ways you might have represented it. So there we go. That brings us to the back, and I know this is one page front and back, so we have, looks like 3 questions back here, and then we'll be finished. So Mai and Tyler are working on the equation 2/5 b plus 1 equals -11 together. My solution is -25, and Tyler's is -28. And so here's their work, and do you agree with their solutions? So since they have different answers, they can't both be right. They could both be wrong, but they definitely can't both be correct, because this should only have one solution. So let's just look at Mai's work first, and then we'll look at Tyler's. So in this case, we have +1. So we would probably need to subtract 1 from both sides in order to keep going. So subtracting 1 would get rid of this here. Subtracting 1 should give us -12 on this side. So I think my solution is going to be incorrect. And then if we had -12 times 5/2, that would give us a different answer than -25. Let's take a look at Tyler's. Now he's doing this differently. We're still going to check that he's correct because it's possible they're both incorrect. So he is leaving this, he's leaving the +1, and he's dealing with everything involving this 2/5 fraction here. So Tyler is multiplying everything here by 5. So if you multiplied everything here by 5, the 5 would cancel here, but we would also have to multiply 5 by our 1 and by the -11. So he does this with the -11 and gets -55. But 5 times 1, last time I checked, is not +1. So I was just kind of speculating, saying they could both be wrong, but I'm pretty sure they're both wrong, because this should be a +5. So in that case, I would say they are both wrong. They're both, oh, not with an E, both wrong. For Mai, I'm going to list her mistake. So she said -11 minus 1 is, I'm saying that's not going to be equal to -10. And for Tyler, we're going to say did not distribute 5 to the 1. Those were the errors that they made. So Mai did some subtraction incorrectly, and then Tyler did not do his distribution correctly. For extra steps here, I might just show, like, this is what's incorrect, and this is what's incorrect if we go from there. Now, they didn't ask me to actually solve it, so I'm not going to solve it and give the correct answer. I'm just going to leave it like that. That brings us to number 3. We want to describe what's being done in each step while solving the equation. So they're working through and solving this equation here, so we don't have to do that work, but we are going to analyze what they're doing at each step. So just from the first one to the second one, it looks like the right-hand side is staying the same. So that means I'm just going to be doing some reorganizing on the left. we're not actually going to change the value, but we are separating things from groups into just um, multiplied out expressions here. So that distribution of that too, that is actually what we're doing. So I'm going to show that. Oops. It distributes to the 4. So I am going to say distribute to negative 3x plus 4. That was their step. They distributed it and got negative 6x plus 8, which is correct. So now, to get from that one to the next one, I see a negative 6 here, but I don't see one down here, which means somehow we rearranged it and we moved that negative 6. So, sounds to me like they went like this and went plus 6 and plus 6. And what do you know? 5x plus 6x actually is going to give us 11x. So I'm going to say add 6x to both sides. Okay. Oops. I was very zoomed in apparently. Okay, so now we have 8 equals 11x plus 2. When we come down here, it's just 11x. So it does look like they moved the 2 or got rid of it. We're going to say that they subtracted 2 from both sides. Okay, and I think we only have one step left really, which is taking that 11 and getting rid of it. So we actually just have x left over. So in order to do that, they need to divide by 11 and on both sides. And that's what's being done in each step. Um, Now maybe I can say that in part E, they rearranged it so the variable was on the left. But I think just adding an answer in between each of these shows what's happening between each step or how we're getting from one step to the next. So I'm going to move down to the last question, which is number 4 here. Number 4 from the back side at least. Andre solved an equation, but when he checked his answer, he saw his solution was incorrect. He knows he made a mistake, but he can't find it. Where is Andre's mistake, and what is the solution to the equation? Okay, so let's zoom in here on Andre's problem and just work through and see what he did at each step and if he might have done some of it wrong. So I see that he has a couple coefficients, and it does look like he is multiplying these out. So we're going to check that first. Negative 2 times positive 3 gives us negative 6x. That should be good. A negative 2 times a negative 5 is going to make positive 10, so we're good there as well. And then I think he's also correct in multiplying here, because we would have 4 times 1x and 4 times 3. So that is just distributing these, and then the 8 would stay. So this step is okay. I'm going to say his first step there, he's all right. But now what is he actually doing? So here I see the left side staying the same, and the right side, it just looks like the 20 and the 8 are being the 12 and the 8 are being combined, and they're creating that 20. So combining like terms is okay. Because we're not necessarily changing the value from one side to the other, we're just rearranging the numbers so that they're all together. So I think we are okay here. Let's, I think I see his mistake. So 10 stays the same, 20 stays the same, but it's our variables here and their coefficients that change. Now, it looks like he was maybe trying to take this negative 6x and get rid of it, but it then looks like he subtracted 6x from this, when he should be adding 6x to both sides. Excuse me. So I am actually going to highlight this negative 2x because that is incorrect. So we're going to say um, Andre subtracted 6x when he should have added it. So I'm going to show negative 6x plus 10. I'm just writing down the previous correct statement and going to go from there. But then I'm going to show in between each one what I'm actually doing. So I am going to show what Andre should be doing, which is adding 6x to both sides. That is going to create 10 equals 10x plus 20. I'm going to subtract 20 from both sides, and that will leave me with negative 10 equal to 10x. Our last step is that we're going to divide everything here. I guess I should stick with red for my actual steps. We're going to divide everything by 10, and then when we do that, we would get left over an x and a negative 1. So our answer should be that x is equal to negative 1 instead of Andre's answer, which was x is equal to 5. And that is the entire assignment. I'm sorry that this video might be out a bit late, but hopefully you were able to work through this on your own and you can check your work with mine. But either way, this has been the 8th grade content from Illustrative Math, but relevant to the Algebra 1.